Hi, Professor.
Hi, Khalid. How are you doing?
How are you doing? I'm good. I'm good.
I'm fine, thank you.
How is your life going? How's your family?
Family is all right. Things are great.
Yeah, everything is good. Everything's good. Life is
Everything
good.
everything is all right. So I'm going even to tell you when you ask one of the questions is regarding how do I manage, I'll tell you a story of my family in the middle to explain that everybody basically loves learning in my family. So I have no problem regarding that because I have two kids, a boy and a girl. And
Wow.
even though, and also my wife, she's a dentist, so it's a completely
Oh,
different area, but she
interesting.
loves learning every day. She's always studying. And my kids, by example, I would say, they are similar to that. They already get, I mean, both are
Uh-huh.
at university. My son, he's finishing his PhD in computer science, working
Uh-huh.
with artificial intelligence, for example,
Wow.
in medicine, applied to medicine. So he
Wow.
has been for some time at the University of Texas in Austin to do some
Wow.
specific research.
Very
And
intelligent.
yeah, and my daughter, she's more an artist. I would say I will talk about that during the
Yeah, yeah,
conversation,
for
really,
sure, Professor. Yeah.
because
Take your
it's
time,
interesting.
Professor. We are not limited for 30 minutes or 40 minutes. Please take your
Sure.
time. It is
Yeah,
for
thank
you
you.
and for us to learn from you, please. So as much as you do. At the beginning, I need to read from the paper because
Sure,
I can't memorize. So
of
excuse me
course.
if I read from the papers sometimes.
No, no worry.
No
But
worries.
let
Yeah.
me tell you another thing. I think that if some responses that I'm going to give are not so good, of course, you can exclude them. And as you are going
Yeah,
to
yeah.
edit it
I
in
will
the
do the
end,
video
I
editing.
think
I will
that's
share it with
it's
you.
important. Sure.
Yeah. Thank you,
So
Professor.
anytime, I'm ready.
Thank you, Professor. Thank you. I'm really
Yes.
happy that you accept to join. Honestly, I appreciate you are very busy. Okay, Professor. I will start. Professor Nilo, welcome to DEALITT podcast, where we like to invite head of companies, CEOs, and professors and professional people like you. Professor Nilo, I would like to do some introduction about yourself. It's very hard to cover everything, of course, but excuse me. Professor Nilo, you are a professor in civil engineering at the Federal University of Rio Grande, UFRGS in Brazil. You're also the head of graduate program in civil engineering at UFRGS. You have been listed among the 0.85% most influential researcher in the world. You are one of the best researchers in civil engineering. Additionally, you are an editor and a reviewer for the best geotechnical research papers and have been awarded the Tilford Prize in 2001 and Tilford Premium in 2009 by the Institution of Civil Engineering in UK. You have published about 300 peer-reviewed paper in several high-impact factor journals, for example, Geotechnique, Acta Geotechnica, Journal of Geotechnical and Geoenvironmental Engineering, ASCE, Canadian Geotechnical Journal, Soil and Foundations, and according to Scopus, you have a high index equal like 55 and almost that great number 10,000 citation. That's really amazing, to be honest. You have also served as a visiting professor in different universities, such as Oxford University. Professor Nilo, how are you doing today? It's really
I'm
amazing
fine.
to meet you.
Thank you very much for inviting me. Thanks a lot.
Thank you, Professor. Thank you. I'm really happy to meet you. Professor, you are really high experience in geotechnical and geoenvironmental engineering and sustainability, and also and geomaterial and geopolymer and nanotechnology and maintaining. Uh, And I mentioned nanotechnology and geopolymer, which is really you've done a lot of work on that. And also, Professor, you've done a lot of work on artificial cemented soil and the reuse of the industrial residue for soil stabilization. And this is a lot of good work and remarkable you done. You have successfully supervised 118 master students. Not easy job. A lot of time, a lot of effort, and also you have supervised 53 PhD students. Correct me if I'm wrong, maybe more, but not
No,
less.
it's right. These ones have finished already. I am
Ah,
supervising a lot more, but
yeah.
these have already finished their work.
Wow, that's really great number. Professor Nilo, how do you feel after this great achievement and long career, and everyone know about you now? It's
Well,
not easy.
all right. If there's a possibility of getting or stay young, or at least feeling like that,
Yeah,
I would say that that's the career that I have chosen is one of the maybe the secrets of it, because I feel every day as if I was just starting. So I wake up in the morning and I am happy about going to continue to do things that I have been doing
yeah,
for the last more than 30 years of experience, let's say. And I still have dreams. I think this is quite important.
yeah,
And when you are working amongst youth, and so every day you see these people with eagering to reach places, to do things, and this is very, very, very nice, really. Uh, and if I would tell you regarding my dreams, uh, I would say that basically to shape people,
yeah,
fantastic
yeah,
researchers to work in industry with the ability to solve new problems, let's
yeah,
say, and through novel developments.
yeah.
This is a thing that makes me wake up every day and feel really happy.
That's really interesting. That's really interesting answer, Professor. That's really motivate us to learn from you and listen from you. Professor, I would really like to go to I would like to dive in the question with you and ask a different question. But at the beginning, I would like to ask you about time management and just continuous development to learn from people and scientists like you. Uh, Time management is really important, and you are busy in time with your research and your lab and with your family, of course, and speaking with the researcher. So the question is, how do you manage your time? It's not easy, I understand, and
Well,
especially to become a worldwide scientist like you, it's not easy. So how do you do it? How do you manage your time, Professor?
I have to tell you that this is not something that is a rule for everybody. But in my case, maybe things were easier in some way because I have a wife and two kids. All right.
Yeah.
Uh, as a civil engineer and working in geotechnical engineering, my wife, she's a dentist. Okay,
Mhm.
and she works with kids. One thing that we merge both of us is that we are lifelong learning guys, people, let's say.
Yeah.
Okay, both of us.
Yeah.
And I feel that it was an example for my son and for my daughter too.
Yeah.
Uh, for example, when I met my wife, she was already a dentist
Hmm.
with an undergraduate degree, and I just have finished my PhD, returning from Canada, where I carry
Yeah.
on my work. And after we met and started married, and so she went for a master degree
Uh-huh.
in pediatric dentistry, and she even nowadays she's specialized now in orthodontics, for example, which is completely different from
Different field.
engineering,
Yeah.
I would say.
Different environment.
Uh,
Yeah.
but nowadays she works in her own clinic with kids, for
Yeah.
example. But she's, as I said, she loves to learn new stuff and
Yeah.
apply those stuff. In
I can
some
see.
way, this is similar to what I feel like to do.
Yeah.
I mean,
Yeah.
in doing research and so. For example,
Uh-huh.
as I said, this might have been an example for my kids. I have a son. And he's just finishing his PhD in computer science. Okay,
They're very smart.
it's
Yeah.
interesting because he's working with artificial intelligence applied to medicine. You see, it's
That's
something
interesting. Yeah,
interesting too,
specialized in
because
medicine. Yeah, yeah, yeah.
even though it is like something more mathematical or thing, but he's applied to medicine. So it's
Uh-huh.
a blend between myself and my wife too, in
Yeah, I
some
can
in
see.
some way. But
That's very
he's more
intelligent.
a scientist, I would say. He's gonna go for science, for sure, for research, and go on in this area. And I have a younger daughter that she's more an artist.
Uh-huh.
She took an undergraduate degree uh, in, let's say, something that was more, well, completely different from my son. As I said, she went for design
Yeah,
to carry out drawings for comics. She
that's
loves
interesting.
Japanese manga. I mean, she loves drawing scenes and so. So she finished that, and right away she started now, a few months ago, really, to learn about computer science too. So she's about to she entered to get a degree
Yeah,
in this area to
yeah.
learn more, and she wants to enhance her skills, to
Mm.
develop modern techniques and get inspiration from these different areas to apply in the thing that she
She
started.
likes to go deep in this area, and she loves
Exactly,
continuous. So
exactly.
continuous learning is part of the family.
Exactly.
Yeah,
So that I would say that to put in a few words that my whole family loves knowledge. I would say
I can see it.
this is something that it's important. I say to have a support in the family. So
Yeah,
I am not a different guy in the family. Everybody
yeah,
loves to go for it. So that was important, an important support, I would say, for me
yeah,
to carry out the things that I'm doing. Regarding at this stage of my career, for example, of course, in the beginning was completely different, but nowadays, after more than 30 years of experience
yeah,
in consulting, in research, and all this stuff,
yeah,
I have several grants from industry now, from
yeah,
mainly from oil and gas and mining industry here in Brazil. Basically,
yeah,
nowadays is mining more than everything.
yeah.
That allows me to have 10 postdocs at this moment
That's
working with
interesting.
me.
That's very
So
good.
and what is nice regarding that is that each one of these postdocs was shaped by me, except one. The other nine came from their background, and so they
Yeah,
worked with me under my supervision. But each one in different areas, and they are specialized in different areas, all areas that we cover here,
yeah,
but different areas. For example, I have one student that she's specializing in nanotechnology. So we
yeah.
merge things with pharmaceutical stuff and things like that with other researchers
Mm.
to develop nanolime, for example, in different
Interesting.
ways.
Yeah,
So this is somebody that loves this area. I also do love it, but I mean, she's
yeah,
specialized in that. I can count on her, for example, when I have to go for some research on that topic, for example.
yeah,
The three pillars of sustainability is also something really
yeah. This is very
relatively
interesting
new.
topic now, worldwide
Yeah,
topic. Yeah, I believe
exactly.
so. Yeah,
And I have two PhDs, postdocs, sorry, that are
yeah,
specialized in this topic in different ways, looking at the three main
yeah,
pillars that you have. I have one of these postdocs that he's specialized in developing mechanical apparatus, new ones. For example, just to have an
uh-huh.
idea, we
Yeah.
are just now building a hollow cylinder from zero. Okay,
Not
why
easy.
why is this important? We could buy, yeah, we could buy. However, if we buy it, we will not learn how the details are. So we decided to build
Mm.
from zero, of course, with support from some friends from University of Bristol, from University College London, that I have so many friends at this university, and so that they already have experience on that, and
Yeah,
other universities too.
yeah,
So I have one guy that is fantastic at this kind of stuff. He cannot just reproduce, but enhance all kinds of equipments, let's say, that we
yeah,
intend to develop. I have another people that work specifically on constitutive modeling for new geomaterials that we are developing, for
Yeah.
example.
So
So
the
you have to
structure of
have
the team is really different, yeah. But
that's
there is a
it.
collaboration between them, which is make your team really, really good and strong and robust.
Exactly.
Yeah, I think so. Yeah.
Exactly. So this is important because, for example, in civil engineering, something quite unusual. I have a guy that's specialized in chemistry, but he's a civil engineer. So
Interesting.
he
Yeah.
has the background that can be used in civil engineering because, of
Yeah.
course, if you are going to talk to a guy from chemistry, you have difficulties in understanding each other. So this made things really, really easier for me. I have some other guys that are specializing numerical modeling and other things like that. Okay.
Yeah.
And even one in analytical solutions, for example. So all and every topics are covered by us regarding geotechnical and
Yeah.
environmental engineering, let's say. And at this
Uh,
moment, I have 24 PhD students. I have six master students and a few undergraduates. How do I manage to do it, to supervise? Of course,
yeah.
without the postdocs, it would be impossible. So I have something like lines. I have the undergraduate that are helped by the masters, that are helped by the PhD, that are helped by the postdocs, and then
And the
they
postdoc.
reach me. So it's
So there
much
is like a
easier.
systematic the teaching and
Exactly.
learning, which is
Exactly.
really well managed. Uh, Professor, if I can take the opportunity, if you
Sure.
ask you a question that continuous development and continuous self-motivation is really important, and you mentioned part of this, uh, and you mentioned the answer of this, but let me repeat the question in a different. What keeps you motivated to continue performing and to continue love the geoscience and geomaterials and nanotechnology? Why, when you woke up in the morning and you say, I would like to keep giving for the geoscience, can I
Right.
ask you what keep you motivating? Yeah, you
Right.
mentioned the
So
family, you mentioned many things. Sorry for
exactly.
interrupting,
But
Professor.
but but I think that you said the word already in your question. I
Yeah,
love what I do.
yeah,
That's the first point. I love to search for novelties. That's my way since I was a kid that I can remember,
yeah,
like producing my own things to play and things like that. So I love to build things, to develop new things. And
mm,
this was, let's say, the fire behind every morning waking up and do things and searching for new stuff that has to be solved. For example,
yeah,
I'm looking for new solutions for old and new problems, let's say.
mm,
That could be said in this thing. What I remember since I was born is that I always get bored if I was supposed to repeat something.
yeah,
I wanted to create a new stuff, something that's my way of
yeah.
thinking. Let's say since I can remember, at least from a long time ago.
That's interesting.
And I consider nowadays, I consider that I do not have a job. I have a position in which I can carry out things that I would do for fun without any payment, but I receive money for it. So could it be better? In my opinion, I have the right job for me. I am
Yeah,
free to develop new stuff and things like that. That's
and new brains and new
what I love
people.
to do.
Yeah, yeah. You're creating a new generation. You're creating a new research, and you have a legacy of that. And you really you mentioned a very important point. You love what you do. This is why you are successful. Professor, I would like to go a little bit deep with the question with you. Consoli index. Consoli index is very important topic, important achievement, and we need to speak about it. To give an introduction, so you made a lot of achievement and on artificial cemented geomaterial and Consoli index. Professor, in 2005, your research team, of course, managing by you done a lot of work on help controlling strength, stiffness, durability, and swelling of artificially cemented geomaterial. It's named now the Porosity Volumetric Binder Content Index. Now is well known by nickname Consoli Index. Professor, can you take me through your journey of developing this index? Now become worldwide and become very well known.
Well, during my master degree in Brazil and my PhD in Canada, I worked with very, very problematic materials, let's say. In my master degree, I worked with organic clay that has a void ratio of about 4. So I had to study about some excavations and that stuff. And well, I have to tell you that it was tough to work with such a horrendous material, let's say, a problematic material. In my PhD, I was the first to develop a solutions for the containment and of tailings behind a dam. I mean, to account for it, to know how much is the amount of tailings that I can put, because you have a problem that with this pivoting in certain points, you have the water continues in a stream that carries the sediments. Then you have at the same time sedimentation and high and consolidation considering large strengths, for example. So and this whole problem I had to solve. So my supervisor was a former student of Professor Roscoe in Cambridge. His name was named Hormos Purushav, and he was the first guy to develop a constitutive model for sandy soils, because usually in Cambridge they were quite famous, and so I mean critical state soil mechanics and this stuff, and applied at that time for clay soils. So after he moved to Canada, he started to develop things that were not exactly in the same direction than were for clay materials and so. Anyway, I developed also a constitutive model. I have to do some testing. So I did several things. And in the end,
it's a journey of success. Yeah,
even
it's a long journey.
I have even to make a numerical analysis at that time, but I built the code just to have an idea.
Really?
Yes, so it was really fun because I had to go for several areas, and I got the solution for this kind of problem to check it out. What was the volume of material that was really capable to be put behind this dam, and so with all these phenomena occurring at the same time. But in the end, I got a material that also had a void ratio of 3, and it was very soft and all this stuff. So that makes me feel not so well, because I think like, well, in all the designs that I have to do in this kind of soils or materials, geomaterials, I have to adapt my design to the soil that you have there. And that moment, I start thinking something different. Why don't I manage to change the material, to enhance, to improve the material, and put it in with some let's say with some parameters, improved parameters, and so that I would be able to do a better design. Let's say. So this is the main search
changing,
that my way of thinking changed at that moment. Instead of trying to solve a problem with a material that was there, why not to change the characteristics of the material? And then you would, if you do know the new characteristics, you can do a better design and a safer and everything in such a solution. So one of the ways, even though I searched for so many, one of the ways was like to start designing, inserting some binder on the material, or compacting it, or doing things, let's say, in such a situation. So I started searching in this topic, and at the moment when I started, and this area specifically, I start talking to people from concrete and things, because concrete is also geomaterial. You use sand,
for sure.
rock, and whatsoever. And they had something named Abraham's law, that was a fundamental law to and I start talking to them to see if I could find out the difference that we have. And then Basically, that Abrams law does not work for compacted materials that are non-saturated. And I tried to get them to get it, and I talked to guys, started teaching, and they could not respond to me because they were used to work with something like the amount, the mass of water divided by the mass of cement, and that controls everything. And that would not control for the material if it's not saturated. So I start searching for what are the real parameters that control it. And the real parameter, I found out that you could not work with mass, but you have to work with volume, because we know that for porosity or void ratio controls soil, a geomaterial. And they used to say, for example, at Abrams law, that you have the amount of water that you have. But they could not, or I don't know if they did not know, possibly, at least the guys that I were working. But the real, who controls is not the amount of water. But in concrete, usually you vibrate. And so you do have the voids 99%, 100% filled by water. And if you have the amount of water, you have the amount of voids, because it's completely.
That's interesting theory. Yeah, this is the point.
And so we develop this index based on volume. So the volume of voids by the volume of cement in the beginning. But volume, you have some index. I mean, it's cubic centimeters, cubic meters, and so we decided to go for some index that was have no indices, or I mean, could be a percentage or so, but not that was measured by in some way. So we start working with porosity and what we call this volumetric amount of cement. In the beginning, Portland cement, but then we started working with lime, fly ash, for example, which is a pozzolan with lime, and nowadays with geopolymers or alkali activated materials. And we found out that this index, it controls not only let's say the basic stuff for concrete and confined compressive strength, but also the stiffness, and the stiffness that you measure through waves, and so which is the largest stiffness, for example, that you might measure through wave, and so. And then we went for expansion. Also, this index controls expansion that you might have. It controls even something that's not measured directly mechanically, which is like the performance way, like durability. If you have a wet and dry kind of stuff, you do so many stages, and so the results are also controlled. The loss of mass, for example, are also controlled by this index. And we are going on trying to search for other variables or mechanical stuff. And up to now, we could measure, I would say, all these values could be in some way controlled by this index. So it's much more interesting than I thought in the beginning, because, for example, concrete is just one example. It also is a global stuff that could work in concrete or any other kind of
material.
Material. Exactly. So that was really interesting.
A big achievement. That's a big achievement. Not just you make it simple, but it's important.
I think that is really quite important for the profession to have a way to design, because one thing that's interesting to call at this point, if the two variables that are important are porosity and amount of cement, and if you have an index which is one divided by the other or so, if you have, let's say, a number, I want to get to this strength, for example, you can get to that strength changing the porosity and the amount of cement. So you have innumerable solutions to reach that strength or that stiffness or that swelling or that durability or so. So it's quite fundamental parameter or index that can allow you to do a perfect, I would say, almost perfect design.
Interesting, Professor. Professor Nilo, I would like to stay speaking about Consoli index. Now, you've done a lot of work, but what is your vision about future vision and future research need for the Consoli index. So what you're looking after for this work? Of
Okay.
course, there's a lot of things need to be achieved.
Yeah.
Mm,
At this moment, we
yeah,
are looking at more sustainable binders, let's say.
yeah,
A binder that would be more sustainable. This is something. So we are developing these nanomaterials and this kind of stuff to
yeah,
see if we can, in the end, using residues and this to obtain improved, enhanced binders to use. And of course, what we have done up to this moment, as I said, this index continue to control all these materials that we have developed, these binders in any kind of soils, in tailings, and well, whatsoever you say.
yeah,
And we have worked in
yeah,
reclaimed asphalt pavement, for example, to use it again. And the index controls so many, not just these things, but also things that are
different
related.
materials. Yeah,
Exactly. That's it.
yeah,
So this is important to continue doing that for
mm,
other materials. But more than that, I would say that this index has been already used by people in Germany, Portugal, here in Brazil, and in other countries in South America.
yeah,
But I think that we still need to disseminate these findings because it's still a small number of people that have the knowledge
yeah.
of it, and that they are really using it in earthworks and so. So we have to start, I mean, to disseminate it to everybody, which
Yeah,
is
this,
not an
yeah,
easy thing, but we are doing it.
collaborating. Yeah, collaborating is very
Exactly.
important. Yeah, Professor, I would like to jump a little bit to other topic, although it's a really interesting topic.
Okay.
I would like to speak about iron ore tailing sustainability and alkali activated cement. It's really a lot of work you've done on this topic. So just to give an introduction, you have done a lot of work on sustainable geoscience materials. To give an introduction, the alkali activated cement is also known as a geopolymer cement, and we use alkali activated cement. We use sorry the iron ore tailing as a raw material for the alkali activated cement. These materials considered to be, as I say, sustainable. If I can ask you, as from your experience, what are the challenges of using alkali activated cement in the industry?
Well, I would say that industry, they are looking for novelties
Yeah,
that can be environmentally sustainable, but
yeah,
also that the cost is not higher than the usual solution,
yeah,
let's say. So one of the things that we are developing now or studying really in this topic for tailings specifically, I'm going to tell you later some more specificity, but we always look for the possibility of working with a circular economy chain, let's say, to have a solution inside the industry in which you
yeah,
do not have to bring things from abroad. So the idea always will be to use the residues produced nearby or inside, really, if possible, inside the
mm,
industry. Uh, or alternatively, if it's not possible, from inside, from nearby, uh, using, for example, a cheaper way of transportation. I have a paper that was published in the beginning of this year in
yeah,
which we have iron ore tailings from the flotation part, which is 95% is silica, for
yeah,
example. And in this case, we are using it to make pavers, like blocks that are produced, let's say, 50 kilometers away. But in this case specifically, we have a rail that passes through. So
mm,
even here in Brazil, even though here in Brazil, the most common way of transportation is through roads, which is quite
yeah,
expensive, let's say, we
yeah,
have in this specific case that it allows just to have an idea. In that case, if you are going to work with roads to be environmentally sustainable, the use of that in some for this production,
yeah,
you would have, let's say, 120 kilometers away would be the maximum that you could be.
mm,
But due to this railway, you could transport 1,500 kilometers and still it
yeah,
would be more sustainable than using the material, the natural material, the raw material that they have there.
The volume is really, yeah, you can save a lot of money, you can save, and it's more sustainable. This is the point, yeah.
Exactly. So this is the real. So instead of having a problem where to dispose this material, of course, this is not a solution for everything, but in this specific case, instead of putting in some place nearby or so, you can use it, and besides of it, it's more sustainable than a usual solution that you use normally up to that moment.
Yeah.
So it's nice.
Thank you, Professor. Professor, if I kind of stay on this topic, but I would like to ask you about a question about one of your research paper. The name of the research paper is, let me mention the name, please. The potential use of iron ore taining for binder production, life cycle assessment. So this is the name of the research paper. It's really interesting research paper for me. So the research paper discussed the life cycle assessment for IoT binder. The paper presents that IoT binder is more sustainable alternative to the conventional alkali activated binder. If I can take it from here as a discussion, and can I ask you a question about, can you elaborate for me the reason behind these results? Of course, it's very good, great results. How this end up to this results, please?
Right. Well,
Thank you.
First I have to tell you what's the motive of this research. Okay.
Yeah. Yeah. Of course. Yeah.
It's important to say that we were looking for a possibility of using cement, some kind of cement, to stabilize tailings and do some dry stacks and so. But these dry stacks are not tiny dry stacks. They are going to design. They are designing at this moment the dry stacks up to 300-400 meters high.
Yeah.
So it's something that has not been done, not in tropical areas at least. So it's something that's interesting. And one of the ways that we have been thinking about turning it safe was to put some binders on it.
Yeah.
So you are compacting, but you also put some amount of binder. And the first thing is, why not to go for an alkali activated and such and so. So in a geopolymer, the classical way, you use metakaolin as a precursor and sodium silicate as an activator to that. So if you are bringing this material from abroad, you have transportation. We are gonna, I mean, it's a problem regarding the cost that you have, the environmental stuff and such and so. And so we started to look after the surroundings, as I said before, to see if we could not produce this material from the residues. And so in the mining area, you have an overburden that you retrieve. And we found out in some places that you have kaolinite. So if you burn kaolinite at a certain temperature, you produce metakaolin. Okay. And from the flotation part, when you are retrieving, in this case, the ore, the iron ore specific, you keep some silica, as I said, that part of it might be used as a base for concrete and such and so. But in another part here, we thought, why not to produce sodium silicate with the silica? So we did it. So we produced both materials inside the area of the industry. And we compare, in this case, the use of this from environmental, specifically in this case, from environmental viewpoint.
Yeah.
We look at sustainability of something that was brought from somewhere else and something that was produced in. And in this case, it was much more
sustainable,
sustainable, both in environmental, in which this is the paper, but we also shown later on that regarding economics also was quite nice.
That's important. Yeah. Thank you, Professor. If I can stay on this paper, although the paper discusses the IoT binder is an environmentally friendly, it's also discussed a future research that there is a need for this binder. For example, reducing the sodium hydroxide and understanding the mechanical behavior of the binder, including the durability and the strength. With all of these points, do you mind do you think there is a need for developing a standardized life cycle assessment LCA methodology for the for this binder and uh, and to compare it with other binder? So we have a methodology to compare to other binders. That will help to make a consistency and a comparability. Or do you think with other binder materials, I mean, or with this limit the thinking outside the box and the innovation thinking? Please
Well,
take me through this. Yeah,
I don't think that is gonna limit. Why?
yeah,
Because you can
yeah,
do whatever you wish. I mean, if
yeah,
you
yeah,
want to
yeah,
go for some other
yeah,
areas, but in this specific case, uh, the concept is when you are dealing with sustainability, nowadays it's expected that you don't look just to carbon footprint as it's usual to be done by
yeah.
most of the people. Okay, you have to look at the three pillars. So you have the environmental, you have the economic, and you have also the
Social.
social. The
Yeah,
social one is still not much explored, I would say.
yeah,
And we are doing some studies in that in the latest papers that we have. And I would say that you what you have to do is look for these tools that you have and use them well because there's enough knowledge to use it for each solution. I would say nowadays, if you are a CEO of some industry or whatsoever, you are
yeah,
interested in sustainability. This is the word that's everybody says
yeah,
because you have even to sell your product through these names and so. And for
yeah.
doing
Of course.
so, it's not a big deal to look at these three pillars. There's enough knowledge nowadays to do so with, as I said, with the knowledge that we have.
Yeah,
But there are people that are doing things in not the correct way. For example, there are so many research that they go just for environmental viewpoint and they look just for the carbon footprint. Well,
yeah,
just to have an idea, carbon footprint, which is regarding global warming and so, is not just carbon. You have methane gas and other gases that are
yeah,
even worse than, but okay, than carbon footprint. But even though looking just to global warming is one of more than 30 uh,
yeah,
specific studies that you have to do, one of them.
yeah,
And this is actually, if you start to look at the general stuff. I mean, looking at these most important points that you have to search for, not
yeah,
just that, and going for the economic and also the social, uh, it allows you to decide. You get a number in the end. And this
yeah,
number, even though you might not be an expert in the area, somebody else is going to do that for you. And then if you are a
yeah,
CEO, you are going to base your decision in something that has been done with confidence and is reliable and such
mm,
and so, then
that's true.
can give you the response. Is it better? Is not so good than the other solutions
That's
that
true.
we are
That's true.
using?
That's true.
So that's the way that I would try
Mm.
to respond to your question.
That's interesting answer. That's really comprehensive answer, Professor. Thank you, Professor. You have extensive experience in environmental soil mixing and geoscience. Uh, can I take a question and ask you what are the limitations of using alkali activated cement comparing to the normal Portland cement, despite its environmental benefits? Of course, both have this.
Well, let me tell
Yeah,
you, the alkyl cements were used basically for concrete and things like that up to a few years ago. And what was the point that was limiting the use? The point was that for getting some strength in a concrete in a reasonable time, you have to put some heat on it. In other words, you have to reach about 80, 90 degrees Celsius in order to have the curing in a due time, for example, 1, 2, or 3 days.
yeah,
So basically, it was used to produce prefabricated concrete stuff.
yeah,
Okay,
yeah,
and okay, but well, you cannot control that if you're going to use, I mean, in an earthwork. How are you going to manage that?
Yeah.
Well, we first, okay, but there are differences between concrete. In concrete, you are looking for 60, 70 megapascal of unconfined compressive strength. In a gel material, you can, if you are working with 2 megapascal, would be good enough. But
Yeah.
even though it's not an easy task for the usual study that we have to get a strength like 2 megapascal or so in a few hours or even in a week.
Yeah.
It's not, you cannot. So you are not, it's, if you're going to tell a contractor, okay, you stay waiting for a month, he's going to say, you're crazy.
No
That's
way.
not going to work. So
Yeah.
we found out that if you add some small amount of lime as a
Yeah.
part of the precursor, you can have the response in a few days, 1 to 3 days,
Yeah.
for getting
Interesting.
a strength that you have. So this is
Interesting.
something that was a problem, but in our research, we show a way of solving that. But there's another problem that still people are searching for. We already found the response, and
Yeah.
also applied mainly for gel materials and so,
Mm.
which is the question of the activator that was used up to some time ago was liquid.
Yeah.
And if you have something, the precursor is solid, the liquid, you blend this kind of stuff, but you know how important it is, the moisture content of your
Yeah.
during the compaction and this kind of stuff. So this is something difficult, unusual, that makes it difficult to
To
use in
control.
the
Yeah.
field.
Yeah.
So
Yeah.
nowadays, we are basically working with what is called one-part alkyl activator, which
Yeah.
is something in which the activator is also solid.
I see. I see.
So we are
Mm.
producing a solid material that is not so different from Portland cement,
Um,
for example,
yeah.
in ways
Yeah.
of
I
using.
see.
So
With
that,
the strength, the durability, the controlling the materials. Yeah. Yeah.
and there's another thing. You also ask why it is better to use, for example, now activated than Portland. It's already proved that if you use alkyl activated, the durability is much higher than the concrete. The concrete, you have 100, 200 years of experience, and it already showed that depending the case, in 50 years is already in bad shape.
Yeah.
You have cases in which they have used nowadays you can call previous initial way of alkyl activations that were
Yeah.
developed by the Romans. For example, the Pantheon that you have in Rome, it has more about 2,000 years, and you have a
Mhm.
dome, fantastic dome, and such and so, and it's there without any problems of durability and such and so. What was used in that case? It was the precursor was the
Yeah.
fly ash from a volcano. That's the
Wow.
Vesuvius
Interesting.
and so.
Yeah.
And they use lime as the activator.
Mm.
Nowadays, we know that lime is a weak alkaline activator, but it is an activator too.
Yeah.
So
Yeah.
the
Of course.
idea of it nowadays, the big difference that we have is that the activators that are used nowadays are stronger. Let's say you get pH higher pH than the one that
Okay.
you
More
can
value.
get
Yeah.
with lime, and so this is the huge difference. But what I said, you have experience of some buildings that still, I mean, standing after
Yeah.
2,000 years. So
Wow. Wow.
durability is something that is a big stuff nowadays too,
Yeah.
and it's already known that durability is one of the strengths of the alkyl activator binders.
Yeah. Thank you, Professor. Professor, I would like to speak about the iron alternating dry stack. You're carrying a lot of research on the compacted filtered dry, compacted filtered tailing dry stack. Uh, why? What type of research you are doing at this stage for this topic, and why is such issue is important? Do you have support from industry in this topic? If I can say, well, it's always an issue for the researcher.
Exactly,
Yeah,
this is quite important, I would say. Well,
yeah,
about 4 years ago, I was approached by Vale, which is the third larger mining company in the world. You have BHP Billiton, you have Rio Tinto, both in Australia, and then you have Vale in Brazil, is the third all over the world. And in their case, we have had in Brazil two failures that were tragic. The first one we have had in 2015, and then in 2019, two upstream dams that failed. And the second one in 2019, 300 people got killed. In the first one in 2015, about 20 people got killed. But in the first one, it reached some important rivers and contaminate the rivers that they still, you do not have fishes nowadays. You cannot, and there are several people that live from fishing and such and so. And in the end, after 400 or 500 kilometers, it even reached the sea. So the Atlantic Ocean was also contaminated. And that was something, I mean, nobody would accept. One,
of course,
and then after 4 years, another. And then this kind of building the upstream dams to dispose the material is not possible anymore here in Brazil. Even more than that, you have to decommission all the existing tailings dams that are built as an upstream dam. So there are plenty of things that have been doing. And 4 years ago, in 2020 specifically, some group of guys, they knew that I was working for a long time with cemented shell materials, and they came here to see about a solution for the disposing with this material using some binders and such and so. So we started a collaboration that at this moment we have 6 projects, about $4 million, I would say, that are allowing me to keep these postdocs and these PhD students and such and so. Because here in Brazil, unfortunately, resources from the government and so are reducing drastically regarding scholarships or this kind of stuff.
Unfortunately,
unfortunately, I think that's most of the world is like that. And so this was a way of keeping and even increasing a lot the research and the solutions. For example, just to have an idea, if you are about to raise a stack which is 400 meters high, what's going to happen to the material that is in the bottom? Is it going to crush the grains? Because mostly you have a sandy size and this kind of stuff. Is it going to change things? What's regarding the critical state soil mechanics for this material in which you might have this crush and such and so? So we start searching
mechanical behavior,
mechanical behavior, but also we continue to develop these binders and everything for these high pressures and trying to develop new constitutive models with these new things that we found out that are different from, because we have an anthropic material, something that's man-made. It has specific characteristics. So what's the effect of mineralogy, of the morphology, and everything like that in the constitutive modeling, and after that, doing things in real scale, the use of new cements with this material or without cement. So we have done in the last years, the last 4 years, things like that. But now we are also trying to solve questions of how, if you have in one mine, you might have 70,000 tons of residues in one day. It's not usual, but you might reach it. Usually it's 30,000. Okay, but you might have. How are you going to compact it with the usual compactors that you have? So we are searching for new ways of compacting it. This is another search. We are doing some search regarding how to decommission safely. Is another project. So
it's a lot of different research questions.
A project on new binders, a project on high stresses, a project of compaction. So there are 6 in the end. And this has been, I mean, as everything is novel, I love it. So I love to do so. And I was able to keep and put so many students from all over Brazil and South America. They are coming here because we have some support and because so many bright people that I'm working, that I have to tell you that I'm really happy about that.
With the bright professor, of course. Thank you, Professor. Professor, I would like to come back and speak about sustainability and environmental impact. And of course, this is one of your main influence and legacy, of course, I would like to say. So, to mention one of your research paper related to soil mixing and sustainability, um, the research paper called "Which Solution is More Sustainable: Waste Foundry, Sand Stabilized with Alkali Activated Binder, or Portland Cement?" This is interesting research paper. So the research paper discussed comparing the sustainability of waste foundry sand stabilization with other two binder, the alkali activated cement and the Portland cement binders. And also, you done a life cycle assessment, evaluated the environmental and economical implication of two dosage, the high density low binder HDLB and the low density and high binder. So speaking about part of the part of the outcome of the discussion, if I only focus on the environmental impact and only part of the discussion of the research paper, uh, the the results show that the alkali activated binder with high density and low binder has the lowest environmental impact. This is what the research say. And the opposite, which is the low density and the high binder, show the highest environmental impact. If I can't take this as a question, how do you see this as a potential uh, sustainable environmental material for the construction industry as a potential? If I can take it as a question, of course, this is a big research topic, and
Yeah.
there's a lot of discussion and there are a lot of things. Sorry.
Well, in 2016, we published a paper. At the time, didn't have
Yeah.
anything to do with tailings or so, but with if you have some, you want to carry out, for example, a base or sub-base of a pavement, and so, what would be more sustainable regarding environmental way if you use one cement? Just choose one, the Portland cement, for example. And
Yeah.
we found out that for a given cement, uh, if you compact more, and because as I said, if you have eta CIV, which is porosity divided by the volumetric cement content, if you want to reach, for example, 2 megapascal of strength, you can do that real, or some stiffness or some durability. You can do that varying the porosity and varying the volumetric amount of cement,
Yeah.
but keeping this a unique number that is related to that strength, that stiffness, that durability. So what we found out in 2016 is that basically, from the environmental viewpoint, always for the studies that we carried out at that moment for
Yeah.
one given cement, you have something that is more sustainable, environmentally speaking, if you compact more to get to such a strength than if you add more cement to get to it. So the
Uh-huh.
solution is already
Interesting.
known regarding this kind of stuff. However, if you start looking at this specific case, for example, that you have, that you are producing an alkali activated cement, and you are going to compare it to Portland cement. Portland cement is something that has been produced a long time ago. That's very specialized, so its optimum has already have been reached. While when you are doing something with residues and so, you have different residues, so different materials that are going to not to respond in the same way. You have always to search for
Yeah.
what was going to be the best solution. In this specific case, as we were looking at the three pillars of sustainability, for example, for the environmental viewpoint, as I said before, people are used to go just for the carbon footprint. As I said, this is only one of the several indicators that you have.
Several material. Yeah.
And you have, for example, ozone layer depletion, you have acidification, human toxicity, just regarding environmental. And this is not necessarily an answer that is going to be the best solution for all the
Yeah,
topics. And so you
of
have to
course. Yeah,
do a calculation so to check it out what's going.
yeah,
Also from the economic pillar, depending if the material is produced inside, or if you bring the residue from somewhere else, and so the transportation, the fuel that is used, and you have to
yeah,
calculate that. From the social too, looking at the that you are, if you are opening new jobs, because you are going to have an industry in which you have to produce this new binder and such, and so if you are going to increase the wage of the people,
yeah.
these are going to tell you
Mm.
what is the best solution. So there's no way of saying, oh, this is the best solution always. And not necessarily, even as it's shown in this paper, if you have in the environmental solution, for example,
Mm.
the alkyl activator might be better and the cost might not be, in the social
Yeah,
might. So you have some indicator, some index too that we propose, but this is still so new. So new. I
yeah.
mean, this social part, we are introducing this kind of stuff.
That's
So
so true.
still,
That's so
we
true.
still have so many things to study, and we
Yeah,
cannot say that this is a final thing that should be already put in a
yeah.
standard or so.
Certainly. Thank you, Professor. This is really a good start, as you said, Professor. If I stay on the environmental impact, your research indicate that the Portland cement contribute with 7 to 8% of the global emission, and this is really high because of the clinker production. If I can take it as a question, can you share your thought on how this can be improved?
I
Of course,
think
there's a
that
lot of things.
yeah, no,
Yeah,
but my view regarding that I look is like we have to search for alternatives, and this is what we have been doing. I mean, with this alkyl
mm,
activated cement, basically using most of the time residues, for example, just in one point, just to be how interesting it is. You have several points to be seen, but for example, to produce clinker, you have to exploit new limestone mines. If you want to have this clinker, also you have to have kaolinite that you burn and everything like that. It means that you are going to exploit, I mean, the raw material. And if you are
yeah,
going to use residues, this is something that you already are winning, for example, from this viewpoint, because but this is just one point to be looked at. If your residue is so far away from it, it's not going to be all right. So we have to
yeah,
search for things, for new cements, new binders, and this is what we are looking at this moment.
yeah.
Maybe this
Different
is what
material is
I've
the
been
solution.
seeing
Yeah,
lately, is that the idea of nanomaterials or nanobinders is one of the ways that we're gonna solve
think about
this
it. Yeah,
problem. Yeah.
yeah. Mm. Professor, continue speaking about the sustainability. One of the methods to assess the sustainability is the sustainability index is MIDEX, considering the three pillars, as you mentioned, the environment and the social and the economic. What is the level of accuracy for existing methods, and how can sustainability technical assessment be improved from your opinion? Is it accurate enough? Do we need to improve it? It's
Yeah.
really. Mm,
As I was telling you regarding, if you look at social is brand new. And economic is not brand, but it's still not well completely understood, and so
yeah,
everything. So we still have lots to study, lots to go. And I would say that the stage that we are now is a nice starting point.
yeah.
Is not still not completely
Uh,
resolve the problem. We have
Resolves
to
problem. Yeah,
continue studying, continue doing things, but I have no doubt that the idea of looking at this sustainability index that merges these three parts of three pillars, and so this
yeah,
is the way to go, but still not completely clear. We have made some trials and to show how it works, and so, but still not the final solution.
not
I
the
mean,
final
final
solution. Yeah,
word still has to seems
to
to be done.
contribute to. Yeah, yeah.
Yeah, that's right.
Uh, Professor, you have high experience in geoscience and soil mixing and sustainability of the geoscience. So, and this required a high, how to explain it, cultural awareness and industrial awareness, education awareness, university. We need to speak about it. So, if I take it from this one, how can we improve the sustainability awareness based on your experience? Because I think this really need to be more educated. Yeah, if I can.
You already responded in education.
Education. Yeah,
Yeah,
yeah, I
you
think
have to
so.
start spreading the word and spreading the knowledge. I mean,
Yeah,
since primary school and this kind of stuff has been already done. The idea, the concept has been, at
the
least here in
concept.
Brazil, it's quite common to have even from the primary school to spread the word. Look, you have to know that you are the future, telling the
Mm,
kids, and we have to go for sustainable solutions. And these you have to care about these, those, and that. So I think
yeah,
that the way is spreading the word that
possible
sustainability
education. Yeah,
is a need.
yeah. Professor, I would like to ask a question about the research challenges and research need. You have very high experience. So if I can ask with the first question, what are the common research challenges for the sustainable geoscience? And what are the research would you like to be highlighted from your experience? So it's two questions in one.
Yeah.
Is there a lot of challenges? There are a lot of needs?
Yeah, but I would say that one of the areas that has we are exploiting and has a lot still to be done is this regarding new binders.
Yeah,
So these binders that you might use from residues, you can get new binders, and these can be used for the solution. I'm talking about one specific area in which I work, uh, but. Uh, the challenges are looking for novel solutions. I
novel
mean,
solution. Yeah,
in any way that can be sustainable, and then
yeah,
we could solve problems in a way that is environmental or economic or social, or at least part of it more sustainable than the ones that we have nowadays. And from time to time, the amount of residues that you have is huge. We have around the world, and we have to look for pointy solutions in each place because we have
yeah.
different residues, different things, and we have to search the solutions for each part of the world,
Each part of it. Yeah.
depending what is the problem, what are the residues, looking from this side of the history.
That's fair enough. Yeah, that's fair enough. Professor, I would like to end up with the final question. I hope I can ask more. Professor, with all of your experience, what is your advice for new researchers, new engineers who are really interested in geoscience, sustainable geoscience, soil mixing, all of these interesting topics? Really?
Right. Okay. I think that my response regarding research is like that. You have to go after opportunities. I mean, looking for the problems and how to solve them. Uh, I know, and by my experience and of talking to so many people all over the world, I'd say, that people might have preference regarding areas or topics that they love and these kind of things. But I have to tell you that from my experience, at least, uh, people do not like some researches or some topics or uh,
Mm,
things that might be quite important, and they don't go to that
yeah,
to study that because they don't know about that. They really do
yeah,
not have the knowledge. And from my experience, is that the solutions
yeah,
that for this fear is to alleviate it through knowledge. So
yeah.
the expression that I had from my former university in Canada, that I love, that I never forgot, and I try to
Mm,
follow that. They used to say that an expression said, knowledge, let it
knowledge.
flower. It might, I mean, it might shape your future. So
Shape your future.
knowledge is
Yeah,
important. You have to know that you are capable of doing so. If you are scared about something, you have to alleviate that fear.
Yeah.
You have to go, and how to do so? Learning. So go after that, and you have the possibility. I used to say that comparing the students that I'm PhD, master, and
Yeah.
postdocs that and if I look at myself at their age, most of them, almost all of them, are much better than I was with their age, at this
Wow.
age, for example. So what I would say, I went to a trail, let's say, to search for knowledge, to go for novel stuff, and I reached this point. They might go much further than myself
Yeah.
because they have, I mean, as I said, when I was 25 years old or so,
Yeah.
I was not so smart as I see these guys nowadays. So they have everything in front of them, and they can reach much higher knowledge, and so that I do have, and I really expect that they are going to do
That,
so
yeah. Yeah. I think,
through knowledge.
yeah, go on, knowledge. I think education is the key, Professor. That's what, that's the point. I think this is how we can build good generation. I think that's what you want. Yeah, that's the point.
Uh,
Thank you, Professor. Thank you for your contribution. It was really amazing, and you are amazing, Professor. And
Thank you
thank you
very
for your
much.
time, and thank you for coming here, and thank you for this opportunity with DEALITT podcast. And hopefully we can meet you again in another session, yeah, with different questions. Thank you, Professor. Thank you very much.
Thank you very much. It was a pleasure for me. Thanks a lot.
Thank you, Professor.
Bye
Thank you.
bye.
Thank you.